Hello everyone, welcome back. This video will be about strings and arrays and how they're related. My name is Zach. I realize I haven't been saying my name, so that's me, Zach. Yeah, so let's jump in. So you can see I have a couple of things defined here. You have a char array, which I've set to a length of 20. And each one of these friendly little fellows there are chars, noted by the single quote. And so a size of 20 is larger than what we need for Hello World. I believe that's 12 characters, if I'm not mistaken. So that's a little bit bigger than what we need, but that will come into play when we execute. I'll show you why I did it that way. Then another, which is this. This is a C style string. So this is Hello World again and Hello World again here for a string type. And these are just three representations of kind of what a string represents. So in the top case, it's simply an array of chars, right? And you can piece those together to make a string. This is a C style string, a const char pointer. Which is very similar to the top. It's a little different, but close to the same idea. And then the string is a string type, which has some extra functionality built into it, some nice things, like this, getting the size and substrings and a couple of things like that. So essentially, though, these are pretty close to the same thing. They all do similar things, and that is holding chars to create a string of characters. So here we're going to output those, and you'll see that they look the same. And then down below, we're going to take a look at how do we get sizes, and the size meaning like the length of the array, right? So this wacky little piece here is the size for an array. This is actually the capacity, so that's going to give you the 20 there. Of that array, not necessarily the things that are defined within that. And so that's how you would get that there. But we're also going to try this on the other two, see what we get. We'll get some kind of strange results. And then we'll do some of the other ways to get the string length that might make a little more sense. And we'll review those as well. So let's go ahead and execute here. And for those who are curious, I've gotten kind of lazy, and I've defined a string here, or a variable. This is bash down below. This is C++, not to confuse everyone. But if you're curious as to how this is working, I'm setting the F to equal this, which is the name of my file, and then I'm compiling with that there and there and there. So now if I do another demo, for example, and I change that, it'll all work exactly the same way. So that's why that's defined in such a way, in case you're curious. Okay, so let's execute. Okay, what do we get? So, as I said, Hello World. These top three, although they look a little different, they're all basically the same when you print them out, right? They're all coming out, you wouldn't know the difference based on that output. Let's take a look at the sizes. So again, I said this is kind of a weird representation of how you get a size of a thing, but it does give you 20. So that's the capacity that we've set for this array. And then you have this size of a char pointer, which is doing the same thing, but on this const char pointer, which is definitely not the same, and it's not an 8 either. So that's 12 characters, not 8. So what's going on there? Not exactly sure why we get that result. Then we have the size of a string. So again, string type, doing the exact same thing. Size of a string here is 32. So in that case, I think the 32 may represent the size of a string by default in bytes. Could be wrong, correct me if I'm wrong, but I think that's what that is. But again, it's not portable, is what I'm trying to get at. This doesn't work the same on the C style string or the string type. But down below we can see we're printing these out, and then here, size of char pointer, which is here, our C style string. The real way that you would want to get the size is here, strlen, strlen, short for string length. And that will give us a length of 12. So 12 are 12 characters that we're expecting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it does line up just as you would expect. And then down below we got the size of a string, and we have these two friendly little functions or methods, size and length. So essentially, as I understand it, these are the same, and they're just different names for the same operation, just to make it friendly depending on what you're used to. If you're speaking in terms of words, oftentimes you would say the length of a word. You wouldn't necessarily say the size of a word. That doesn't make sense in English as well as length might, right? So I think that's the idea here, is that these two things basically give you the same result. They're just two different names for the same thing. That happens sometimes for compatibility's sake, but that's what that is. And that will give you the correct size as well here. So we get a 12. The same thing we would expect here. So why is this different? Well, that's because that's an actual array. It's not counting the pieces that are not defined. It's counting the capacity here. Okay, so now I have a nice little for loop here that I will reveal. And we're going to iterate 20 times, so the length of our array. We're going to print out the index, and then we're going to print out the char at that index. So we're going to see some interesting stuff here. Let's go take a look. Let's execute. Okay, a lot of output. Let's scroll back up to the top. And in the beginning, you're going to see H, H, H. So kind of as you would expect, right? So up here, the first index is H, then H here, first letter, right? And as you can see, it's printing out the same thing for each one. So you got your hello, you got a space, and then you go down, you got world, you got your exclamation point. Hurrah, we got it. Now, on the 12th character, actually the 13th character, 12th index, there's a blank space. After that, what do we see? We see some junk. Some junk data. We don't have this in our string, right? But it's junk data. This is something in memory somewhere that we're accessing by accident because we've gone beyond the index of the array that we're expecting to look at, right? Pardon me, bumped there. But this can happen, right? You're looking into the memory beyond what you've told it is important. So we only care about, in our code, hello world, which is the 12 characters, right? And a terminator character that is included. But beyond that, the memory has what it had in there before, right? It's whatever was there, whatever data was held in that particular space. And that's what we're seeing here, is a bunch of stuff come through. But as you'll notice, our array, the my R definition, does not have this going on. You see just blank spots here for the top one all the way down. And why is that? Is because we've defined this as a length of 20. And so what's happening is that even though we've only told it we want these characters defined, everything else beyond that was empty, essentially. But we're saying we want to reserve this space for 20 things, right? We didn't use all 20, but it's reserved. And so there is no junk data there to be seen. So that's kind of a quick look at strings and how underneath they're arrays of chars, right? They're just a collection of these char characters, and that's what you got. And so it kind of gives you some insight as to how some of those things work behind the scenes. So hopefully that was informative, helpful, insightful, whatever floats your boat. Thanks for stopping by. I'll probably do another discussing more complex things like a multi-dimensional array, that type of thing. So be sure to check that one out when it's available, and thanks for stopping by. Appreciate it. Have a good day.